Jason Hayes, Product Manager of Trimble RealWorks. I'd like to thank you for your interest in the Trimble RealWorks viewer. This quick start video will show you the basics to help you get started viewing and analyzing point cloud data. The video begins by giving an overview of the layout of the software. Next, it goes through visualization and navigation. And finally, it demonstrates how to use some of the most commonly needed tools for point cloud analysis. So let's get started. The software has two working modes, registration and production. Each mode has its own set of unique tools. The registration mode has tools specific for analyzing and evaluating the quality of the registration. The production mode has tools dedicated to viewing and analyzing the data. For each mode, there are three tabs: the File tab, the Home tab, which is where you'll find most of the tools, and the Support tab, where you'll find information about the software, help files, and the project preferences, where you can change display settings, such as the background color and the units of measurement. You can also find a shortcut to the preferences in the lower right-hand corner of the software. Beneath the Tabs and Tools ribbon, you'll find three main windows: the Workspace, the List window, and the 3D view. The Workspace is where you can find and select the project and main folders. It has two main tabs, one for viewing point clouds and models, and the other is for viewing any images that may be in the project. Some tools, such as the cutting plane, also use the Workspace. The List window is where you can see and select the individual objects in a project. These objects, such as the point cloud and CAD models, are the contents of the Workspace project or folders. So, you can see that if I select the project in the Workspace, all of its contents are displayed in the List window. If I select a specific folder in the Workspace, then the contents of that folder are displayed in the List window. To go back so that I can see the contents of the whole project, I can simply click on the project in the Workspace, or in this case, I can also use the Go Up to Parent Folder button. The List window is used mainly for selecting, displaying, or hiding objects. To select an object, simply click on it. To display or hide an object in the 3D view, click on the light bulb beside that object. The List window also shows information about the type of object and other properties, such as the number of points or color of an object. Right-clicking on an object in the 3D view, Workspace, or List window will display a list of commands applicable to that object. Now that we've identified the key elements of the viewer interface, let's import some data and take a look at it. To open a Trimble RealWorks project or import data using a different file format, make sure that the Home tab is active, click on Import, and select Open. Here in the Open dialog window, you can see a file named Hallway. There is an RWP file, which is a RealWorks project file, and with it, there should always be an associated RWI folder, which contains all of the RealWorks project data. Now, if you don't have a Trimble RealWorks project file, but you still need to look at point cloud data, select the drop-down list for the file of type, and then select from the options, such as PTS or ASCII. But in this case, I'm going to open the RealWorks project, so I'm going to select the Trimble 3D Scanning Files option. Then I'm going to click on the Hallway RWP file, and then click Open. To freely navigate the data in the 3D view, I'm going to check that the Home tab is active, and then on the Tools ribbon, I'm going to go to the Navigation group and make sure that Examiner is selected. This will allow me to freely zoom, pan, and rotate around the data. Use the scroll wheel on your mouse to zoom in and zoom out of the point cloud. To pan, hold down the middle mouse button as you move the mouse. To rotate, Left-click and hold down the button as you move your mouse around the scene. If you'd like to change the behavior of the mouse, you can do this by going to the Support tab and selecting Preferences. Then, on the Navigation tab, you can select the behavior for rotating, for panning, and even for zooming. Next, let's take a look at the different options for viewing the data. We're going to focus on these 5 groups in the Tools ribbon. The first that we'll look at are the 3 viewing modes. The first mode is Examiner, which we've been using. It allows you to rotate around the data as well as zoom and pan. The next mode is Station-based. It allows you to view the point cloud from the position of the laser scanner. You can rotate the view using the left mouse button and zoom using the middle scroll wheel. To select a specific station to view from, use the Station Selection button at the bottom of the screen. Alternatively, you can click on the station markers. To display the station markers, click on the Show Stations button. You can then change the view to a specific station by simply clicking on the orange station marker for that station. To hide the station markers, click once again on the Show Station Markers button. Next, let's take a look at the walkthrough view. In the walkthrough view, use the mouse scroll wheel and left-click to move and look around the 3D view as if you were physically walking through the scene. Scrolling the mouse wheel will move you forward or backward, and holding down the left mouse button while moving the mouse will rotate the view around a stationary position, similar to the station-based mode. If you need to quickly see the entire project, use the Zoom Extents button found in the Zoom group. If you need to zoom in on a specific area, use the Zoom In window option. Simply click the icon, and then left-click and drag a window to fit the area that you'd like to zoom in on. If you would like a specific area of the project to be in the middle of the screen, use the Center on Point button. Then click on the area that you would like to move to the center of the screen. Sometimes it is useful to see the data from a specific view. This can be done using the Standard Views button in the View group. This will allow you to view the data from a specific position, such as the front, top, or sides. Now let's take a look at a few more display options. We've already seen that you can use the light bulb to display or hide an individual object in the list window. What if we have multiple objects selected? We can use the Display Point Cloud in the Display group to display all of the objects at one time. Now we can also select all of the objects in the list window and then click on one of the light bulbs and they will all hide. But sometimes maybe we have objects in a folder, like here we have 2 objects. If we select that folder, then we can choose to display only the point cloud objects or also display the geometry objects. It also makes it easy to hide objects inside a folder. Simply select the folder and click on Hide Geometry or Hide Cloud. It's also very easy to quickly hide all objects on the screen. Simply click on the blue icon that's labeled Hide All. Now let's take a look at a few of the cloud rendering options. Just displaying the main project cloud, and here in the rendering group, you can see the cloud rendering. First option is white. Pretty straightforward, just turns the point cloud white. The next option is cloud color. This option will simply display the point cloud using the color associated with it. So if I look here in the list window, you can see these different cloud objects all have yellow associated with them. You can see here yellow shows up in the display. Now if I select one of these objects and then right click, go to the properties, I can click on the color property for that and then select from the color choices available. So in this case, let's select green. So now this point cloud has green associated with it. So if I display the other point clouds, you'll notice that they will come up and they'll display in yellow, but that selected object, because I chose green for it, will be displayed with green when using the cloud color rendering option. The next rendering option we'll take a look at is station color. Station color is very useful when doing analysis on the point cloud registration. Makes it very easy to see how one station matches up to the stations beside it. The next option is grayscale. This is very simple. It's just like a black and white photo. Then we have true color. If you have your point cloud colored from images, which case we don't, you would see that here. And then the next is rendering the point cloud based on the intensity of the return from the surface to the laser scanner. And last is color coded by elevation. Now there's a few settings we can change here in the cloud rendering settings. We can go in and make changes to the contrast. So if I was to zoom in on the point cloud, you would be able to see as I move the contrast slider, it'll make it more easy to see specific objects and more difficult to see others. So you can move that where you want. And in addition, you can use the brightness adjustment. So using these two in combination with each other, you can dial it in to see the specific details, such as cracks in a floor or a wall or something like that. Now, in addition to the intensity, we also have settings for the rendering by elevation. You can see the color bands. We can adjust the interval that these bands repeat. So let's just change this up to a couple of meters. And now you can see that the bands will go kind of more of the length of the wall. Now, in addition to the interval, we can also change the origin where the color band starts. So if I just click in the bottom here, my color band will start there at the bottom of the floor and then go up and repeat every 2.2 meters. All right, so now let's go ahead and take a look at some of the specific tools we can use to go in and analyze our data. We'll start out by looking at the limit box. The limit box allows you to isolate and visualize a specific area of the project. It opens with a small toolbar, and you'll notice that the icon for the cursor is changed. It wants me to click on the position where I would like the center of the limit box. So I just need to click right here, and now that will become the center of the limit box. You also have the option to change the shape, the size, position, and orientation of the box. To do this, you can click on any of the grab handles. In this case, if I want to change the size, I can click on the red corner grab handle and move the mouse in towards the object or out to evenly change the size of the box. You can also change the shape of the box by using the grab handles for any specific face. In this case, I'm using the blue one to move along the Z-axis. You can also move along the X or Y axis. In addition to changing the shape of the box, you can also pan to move the box. This is done by clicking on one of the grab handles. It can be any of the corner or specific face handles. Just click on it and you'll see it'll toggle through now to allow you to pan the box along any of the axes. Panning the limit box is a great way to inspect areas such as corridors. If you need to rotate the limit box, click again on the grab handle to bring up the controls, which will allow you to rotate the box along different axes. You can also use the buttons on the limit box toolbar to change between panning, changing shape, and rotating the limit box. Another useful tool for isolating the point cloud is the segmentation tool. But before I open that, I'm just going to do a bit of housekeeping. I'm going to right-click in the list window, choose New Group, select that group, and then give it the name of Archive. Then I'm going to select all of these objects and just drag them into that folder. Next, I need to select the point cloud to open the segmentation tool. So if I click on it, you'll see the segmentation tool is available, as well as many other tools. But if nothing is selected, you'll see a lot of tools are grayed out. So I need to select the point cloud, either in the list window or the 3D view, and then click on segmentation. To isolate the area, I'm just going to start left-clicking to create a fence. So I'm just left-clicking around here, and then I'm going to double-click to end the fence. Then I need to either keep that area in or take it out. I'm going to keep it in by clicking the green check mark. Now I'd like to see my point cloud a little bit better, so I'm just going to increase the pixel size up to 4 pixels. And then I'm going to just click around this area I'd like to remove, just left clicking. And then I'm going to double click or right click and choose End Fence to close the fence. Now instead of keeping this in, I want to take it out, so I'm going to click on the red X or use the keyboard shortcut of O to remove those points. I'm just going to rotate to the side just to make sure I got everything. There's a few more points I want to remove. So again, I'm just left clicking around those points, double clicking to end the fence, and then I'm going to click on the red X to remove those points. Now there's other options. I could use a rectangular segmentation, but in this case the polygonal worked the best. And then just click the Create button to save that object. That specific area has now been created as Object 64, which you can find in the List window. Just need to click on the door to close the tool. And let's just change our point cloud size back to 1 pixel. If I wanted to give that object a name, I'll just click on it and then type in a name such as door area. It should be noted that objects created while using the Trimble RealWorks viewer are not saved when the project's closed. Objects are only saved when using a full licensed version of Trimble RealWorks. I'd like to thank you for taking the time to watch this quick start video on the Trimble RealWorks viewer.